Aloha, this is a solution to problem 94, sorry, in chapter 4. So we're shown a drawing like this, two blocks made of different materials connected by a thin cord, slide down a plane ramp, inclines at an angle theta to the horizontal. Block B is above block A. The masses of the blocks are MA and MB. The coefficients of friction are mu A and mu B. If MA is equal to MB is equal to 5 kilograms, and mu A is 0.2, mu B is 0.3, determine A, the acceleration of the blocks, and B, the tension in the cord, with theta being 32 degrees. So I just like to start by writing down our given information. Hold that MA is equal to MB is equal to 5 kilograms. Mu A, and we are asked to find the acceleration A and tension, which I'll label T, in the cord here. So presumably the blocks are sliding down, and that means friction, which will be a different value for each of these blocks since they have different coefficients, is going up the ramp. And since we could just, I'll solve this problem assuming MA and MB are different, but if you wanted, you could also just define this to have a value M, but I'll solve this problem in general. So we want to start by drawing a free body diagram for each of these blocks. Start with A. We have the gravitational force going straight down toward the center of the Earth. A normal force will be coming up perpendicular from this inclined plane. And it has a frictional force going up the ramp. It's the normal force, as well as a tension in the same direction from this cord. And we can also draw a free body diagram for block B. Gravitational force on it. A normal force coming from the plane, perpendicular to the plane surface. A frictional force in the opposite direction of the motion down the plank. And now the tension is going toward block A. So we can use Newton's second law, F equals ma, to sum these forces and figure out the acceleration. So it's probably convenient to define a coordinate system so that at least two of these forces are along the axes. So I'll make the coordinate system for both of these like this, the normal force going up in the y direction, and the friction force going in the positive x direction. And if we're wrong about this assumption, I'll assume A is negative going down the plank, but if that's not true, we'll get a positive answer for A. Or we'll get a negative answer, I guess. Yeah, it'll be opposite what we start out assuming. So we also know the frictional force is going to be for block A. Block B will be different because they have different coefficients of kinetic friction, possibly different normal forces because they're different masses, so we'd expect that. And I can redraw these free body diagrams so that we have an image that we're more familiar with the y-axis directed upward, our page. We'll do this for block A. And the tension force is the same because it's the same chord. And the acceleration is the same because they're stuck together on this chord. But right now we're just looking at block A. And we want to figure out what this angle is here in terms of the angle for this, for the ramp. So this is the surface of the inclined plane. This is perpendicular to it, and this is going straight down. So if you draw something so that there's a perpendicular corner right here, we'll basically reproduce the drawing that we have before of this ramp. So that means that this angle here, this will be theta. That angle there will be 90 minus theta. But because the corner of this right here is a 90-degree angle as well, we know that this angle here will be theta. So that 90 minus theta and theta will sum to this 90-degree corner right here of our coordinate axes. So we can write down an equation for the net force in the y direction, which will be 0, because there's no acceleration off of the surface of this plane. So n minus the component of mg in the y direction. This will be the hypotenuse, and the y direction will be the adjacent side of this angle right here in red. So this will be mg times cosine theta, picking out this adjacent component, the component in the y direction. This is 0, so we know that n is ma times g cosine theta. And in the x direction, we do have acceleration. In the negative direction, it's going down this plank. And we have the negative direction of x, the way I've defined it, we have, let's start with the positive direction. We have the tension and the frictional force. And we have the gravitational force component in the x direction, pulling it, going in the negative direction, pulling it down. So we have, and we have the sine angle picking out that component along the x-axis here. And we can rewrite this with the frictional force replaced by the equation that we know. So remember, we're searching, we want to find A. Now we can do this analysis for block B. Very similar. Normal force, friction force, but now the tension force is going in the opposite direction because it's connected to block A, which is below it on the ramp. And So we have no motion in the y direction. And the angle here is just like in our other diagram. This is theta. And the y component will be picked out by the cosine. And in the x direction, again, we have an acceleration. In the negative direction, as I've defined it here. And we have in the positive direction, the friction force. And in the negative direction, the tension, as well as a component from the gravitational force. We need this x component coming from the sine of theta, the opposite side of that angle. So now we have two equations. We know the masses, MA and MB. We know the coefficients of friction. These are given, but we don't know the tension. I'm just going to sub in our equation for the frictional force from what we calculated with the n up there. G is a constant of nature, so we need to rearrange these two equations we have coming from Newton's law in the x direction for the two blocks. We need to substitute in the tension force from one equation into another to get an equation where A is the only unknown, so we can solve for A. So I'll just rewrite these two equations that we have. So that's from considering Newton's second law in block A. What we just did for block B, we have and we can just add t to both sides and just use the second equation. Doesn't matter which. But if you add t so that you have t over here and add this over onto the other side of this equation, we've got an equation for t. So really just doing some algebra here. And now we can plug this equation for t into this equation here, into the t here, and then we'll have one big equation just in terms of A and known variables. This is plugging in t. So we can rearrange this and group some things together. We're going to want to subtract this term here, so we have A on one side of the equation. So we have MA plus MB. Can factor out the G, acceleration due to gravity, and we can also factor out the masses and write these. just like this. So that should be a minus sign there. But jumping ahead, if I want to just divide by this minus sign, I can make this a plus sign, put a minus sign on this term, put a minus sign on that term, and make this a plus sign. So I just divide it by -1. So we have A is G times divided this top term here from this one side of the equation divided by MA plus MB. So then you can just plug in numbers, and this will be our answer for the value of A. And MA and MB are both the same. So we can factor out that 5 kilograms. And then we'll have, since they're the same, 2 times the sine of this angle, which we were told is 32 degrees. Mu A is 0.2. Mu B is 0.3. And this will really be 10 kilograms on the bottom. So if you just plug in these numbers into a calculator, making sure that you're using degrees and not radians, using these angles here, you should get something that will approximate as 3.1 meters per second squared. And then the final part of the question was asking for the tension. We already wrote down an equation for tension. So I'll just rewrite that here. We can just plug in the value of A we just calculated. This is just, it doesn't matter which one you use. You could use the equation for block A or block B, same tension because it's the same rope and the same acceleration because they're moving together. But since I already wrote this one down earlier, we can just plug in the value we calculated for A. And I would recommend using, I wouldn't approximate A here. I would use as many digits as you can when you plug this into a calculator, and then approximate just in the final answer. And then you should get an answer of approximately 2.1 newtons.